Dear students, let us continue our discussion on air conditioning. Another term for air conditioning is called psychrometry. It is simply the study of air and water vapor. So in our air conditioning or psychrometry, both are same. In psychrometry, we deal with air and water vapor, not nothing much. So now let us focus on the various relations coming up in our air conditioning, or it is called psychrometric relations. We have studied in our junior classes the Dalton's law of partial pressures. It is called the total pressure of the mixture of gases will be equal to the sum of the partial pressures exerted by each gas when it is occupying the same volume of the mixture of that air and at the same mixture temperature. So when we are applying this Dalton's law of partial pressures to our moist air, or in our specific case of air conditioning, we can write this relation. Pt will be equal to Pa plus Pv, where Pt is the total pressure of the moist air. Moist air means sum of dry air and water vapor. Then Pa is the partial pressure of dry air. Pv is the partial pressure of water vapor. Okay. Then another term, that is, we have already learned the specific humidity. How did we define this specific humidity? It is the ratio of mass of water vapor. It is the amount of mass of water vapor associated with the unit mass of dry air. It is represented as omega, Greek letter omega. So we can mathematically, now let us try to define this. Now let us try to give a mathematical relation to represent this specific humidity. So it can be written like mv by ma. mv is the mass of water vapor associated with ma, unit mass of dry air. Ma represents the unit mass of dry air, or 1 kilogram of dry air. So how we can write this mv by ma? Now let us take our ideal gas relationship. Pv is equal to mRT, or PAVA will be equal to MARATA. Okay, where PA is the partial pressure of dry air, VA is the volume occupied by that dry air, MA is the mass of that dry air, for example say 1 kilogram of dry air, RA is the characteristic gas constant of that dry air, TA is the particular temperature at which that dry air will be present. So MA can be written like PAVA by RATA. In the similar lines, MV, or mass of water vapor, can be written like PVVV divided by RVTV. The subscript V stands for vapor form, that is the water vapor. The subscript A stands for dry air. So when we are writing the expression for specific humidity, we can write it. Specific humidity will be equal to PVVV by RVTV into RATA by PAVA. So that will be coming around PV by PA into this RA by RV. RA is nothing but the characteristic gas constant for dry air. In junior classes already we have studied the value 287 joules per kilogram Kelvin. Then from various experiments conducted by the eminent scientists, the characteristic gas constant for water vapor was also found as 461.889 joules per kilogram Kelvin. So this ratio will be coming around 0.6222 times PV by PA. Okay, but PA can be written as, how we can write the PA, or partial pressure of dry air? Partial pressure of dry air can be represented as Pt minus Pv. Okay, so instead of Pa we can write this as Pt minus Pv. So this beautiful relation comes into picture. Omega will be equal to, or specific humidity can be written as 0.622 times Pv by Pt minus Pv. So you have to remember this relation. Okay. Then now let us try to give a mathematical form to our relative humidity. How did we define this relative humidity? Relative humidity, contrary to our specific humidity, or humidity ratio, which was defined with respect to unit mass of dry air, our relative humidity phi is defined with respect to unit volume of dry air. So what is the amount of water vapor associated with the unit volume of dry air divided by what is the same what is the amount of water vapor associated with the same volume of the dry air, but if that volume of dry air is completely saturated. That is why mv divided by AV, mv per v, mv stands for the mass of water vapor per unit volume of dry air, that is V, divided by mvs. S stands for saturated condition of that volume of dry air V. So this unit volume we can cancel out. So this expression will be turning out like this, turn out to be mv by mvs. Okay, so using our similar PVT relationship, we can write this PVVV by RVTV times RVS TVS by PVS VVS. So RVS and RV, we are talking about the characteristic gas constant for the same water vapor, so we can cancel out this RVS and RV. Then TV and TVS, both are representing the same temperature of that same volume of dry air. Okay, so the only variable remaining is PV and PVS. PV stands for partial pressure of water vapor at a particular instant divided by PVS. PVS is the partial pressure of water vapor when that water vapor is when we are talking about that volume of dry air, if it is completely saturated with the water vapor. So phi or relative humidity can be written as PV by PVS. Okay, so all of you write these relations and then study. Write these relations on a piece of paper. Then only you will, these relations will be keeping, that is, it will be remaining in your mind. Then next term that we have to discuss is degree of saturation, or represented as Greek letter mu. We have already studied this, how we can represent this omega by omega s. We have studied we have discussed in our last session in the introduction to air conditioning. That is, degree of saturation mu is represented as omega by omega s. So omega was 0.622 times PV by PT minus PV. Omega s was 0.622 times PVS by PT minus PVS. So the subscript S stands here for the saturation condition of atmospheric air. Or we can write this, mu will be equal to 5 times we are bringing in the terms for relative humidity. Relative humidity was PV by PVS. So instead of PV and PVS, we can write in terms of the relative humidity phi. Okay, so mu or degree of saturation mu, it can be written as relative humidity phi times PT minus PVS by PT minus PV. When we are opening this brackets, we can write this mu times PT minus PV will be equal to 5 times PT minus PVS, or mu times PT minus 5 PVS will be equal to 5 times PT minus PVS. Okay, so when we are simplifying this relation, we can write it like this: mu will be equal to 5 times, opening the brackets, 1 minus PVS by PT in times 1 minus mu. But when we are considering this ratio or this fraction, that is PVS by PT, PVS means partial pressure of water vapor when it is fully saturated. Okay, PT represents the total pressure exerted by both dry air and water vapor. So compared to the value of PT, PVS is a very much lesser value compared to PT. So it is, we can almost neglect this relation, that is, neglect this fraction PVS by PT. So we can assume, or we can say that degree of saturation is almost similar to relative humidity. Okay, or in a way, relative humidity can be assumed similar to degree of saturation mu. Then another term that comes commonly into picture in our discussion of air conditioning is dew point temperature. Dew. Okay, so you might have observed our morning dew. Suppose we are parking our automobiles, or if you are waking up early in the morning, if you go out and observe, you might be seeing tiny droplets of water vapor, so tiny droplets of water sticking onto the automobiles parked outside, or on the leafy or on the green leaves of the vegetables. But we know that there was no rain during the night. But what happened? If the temperature of air is reduced by continuous cooling, at one point the water vapor in that air will start to condense at a particular temperature, and that temperature is called as dew point temperature. Okay, so how this morning dew is formed? During the night, the temperature of the atmospheric air will slowly it will get reduced little bit by little bit. Okay, so after reaching a particular temperature, the water vapor content in that atmospheric air will start condensing on all the available surfaces. It can be the surface of automobile, it can be the surface of the green leafy vegetables, etc. Green leaves of the vegetables, trees, other vegetation, etc., etc. That is what it is this condensed water vapor, we are seeing it as the morning dew. Okay, so this phenomenon, or the temperature at which this dew formation is happening, is called as dew point temperature, in short DPT. Okay, so with this idea, let us try to solve some problems in air conditioning that we will be discussing later.